Okay, so we're going to be solving trigonometric equations today. And so don't forget when we did inverse trig equations or expressions before, we had these. And so, just as a refresher, the inverse sine of negative root 2 over 2. Well, we looked at where the sine was, where the sine was root 2 over 2, which is pi over 4. And because this is a negative, this is a negative. For cosine of negative root 3 over 2, we looked for where the cosine was root 3 over 2. The cosine is negative root 3 over 2 at 5 pi over 6, so the answer is 5 pi over 6. We had a limited range for these values, but if you look at the unit circle, you can see that negative root 3 over 2 is a cosine value for two angles, 5 pi over 6 and 7 pi over 6. When we took inverse trig values before, we limited the domain, which was what we did before. When we have equations, we don't. So the first one is we're going to look at the solutions for x inside of this domain, so between 0 and 2 pi. So that's just the full unit circle. So let's solve this first one. So if we have 4 cosine squared of x minus 3 is equal to 0, it looks bad, but really we just want to break it down to this to get the trig function by itself. So we can think about it by boxing this and saying, all right, I want to get this by itself. So I'm going to add 3 to both sides. So cosine squared of x is equal to 3, and then divide both sides by 4. So I get cosine squared of x is equal to 3/4. Awesome. And this is cosine squared. I want cosine. So how do you undo a square? You take the square root. So cosine of x is equal to the square root of 3 over the square root of 4. So we get that the cosine of x is equal to, because we're taking a square root of 4, that's 2, but we also have a plus or minus. So the cosine of x is equal to plus or minus root 3 over 2. So we look, where is the cosine of x equal to positive root 3 over 2 and negative root 3 over 2? Well, inside the unit circle, inside this domain, we're going to have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So, So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So basically, everywhere on the unit circle where we have either a positive root 3 over 2 or a negative root 3 over 2. That's it. Over here, yet again, isolate this in there. There's a 2x in there. We'll worry about that later. So we get that the sine of 2x is equal to 1 over the square root of 2. So if we rationalize the denominator, we get sine of 2x is equal to square root of 2 over 2. So this is asking us now, all right, where do we take the sine and get root 2 over 2? Well, we're going to get the sine for root 2 over 2 at pi over 4 and 3 pi over 4. So 2x is equal to pi over 4, and 2x is equal to 3 pi over 4. But what do I want to find? I want to find x, not 2x. So I just have to divide both sides by 2. So here I get x is equal to pi over 8. And here I get 3 pi over 8. Okay? And then finally over here, 3 cotangent squared of x minus 1. So again, isolate this value. So I get cotangent squared of x is equal to 1 over 3, which I have to take the square root of. So that means the cotangent of x is equal to 1 over the square root of 3, but because I take the square root of both, I get plus or minus. So cotangent of x is equal to plus or minus root 3 over 3 after rationalizing the denominator. Well, root 3 over 3 for cotangent of x, don't forget cotangent, that's x divided by y. So where do I take an x value, multiply it by y to get root 3 over 3? That's going to happen where my y coordinate is root 3 over 2. So that's going to be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So x is equal to pi over 3, 2 pi over 3, 5 pi over 3, over 3, said 3 over root of 6, 5 pi over 3, and 4 pi over 3. I missed the 4 pi over 3. So we're just finding the values here where this occurs in the unit circle. So with the cotangent or the tangent, there might be a little bit of work. When we have a 2x in there, we have to actually solve that. But most of the time, it's just going to be simple like this. Now, what if I don't have this restriction on the mean? What if I'm not looking for values just in the unit circle? So now I have questions that ask for the general solution. So this is all values, ever. Because don't forget, in a unit circle, we could keep going around and around and around and around and around an infinite amount of times. So with this one, we want to treat this the same way. So let's find out what x is, or get this sign by itself. So we get sine of x is equal to 1 over 2. So where's the y value 1 over 2? Well, pi over 6, 5 pi over 6, and then if I go full circle around, 7 pi over 6. And then here, a full circle around would be 17 pi over 6, so on and so forth. Round and round we go. So what I want to do is I want to think about just the first value. So where is this sine of x equal to 1/2? Well, first x could be pi over 6. And x could also equal, as we just have shown, 5 pi over 6. But then we want coterminal angles. So how do we get a coterminal angle for pi over 6? Oh, we add 2 pi, or another 2 pi, or another 2 pi. So when we have those multiples there, we're going to add a certain amount. So I'm going to write 2n pi. Oops. This n stands for any integer value. So when n is 1, I add it 2 pi. That's the next coterminal angle. If n is 2, that's 4 pi. That's 2 times around the unit circle. When n is 3, that's 6 pi. That's 3 times around. You can also have negative values. So negative 1 would be negative 2 pi. So that's going around in the counterclockwise, or sorry, the clockwise fashion. So those are all acceptable answers. So that's what you need to do in order to get your general solution answers. For the next one, we have tangent squared of x is equal to 1 over 3. And so we can take the square root of this. So we get tangent of x is equal to square root of 1 over square root of 3. So that means that the tangent of x is equal to plus or minus 1 over root 3, which we rationalize to get tangent of x is equal to plus or minus root 3 over 3. And so now this is going to be like the previous problem we looked at, except we're looking for tangent, and tangent is y over x. So where is y over x root 3 over 3? And that's going to be for the values of pi over 6. So actually take a look at what happens here. So pi over 6, root 3 over 2, negative root 3 over 2, negative root 3 over 2, and root 3 over 2. So for questions like this, how do you get from a positive root 3 over 2 to the next positive? Or sorry, how do you get from a root 3 over 2 to this value? You don't add the full circle, you add half the circle. So first value for where this occurs is pi over 6. The next value for where this occurs is 5 pi over 6. And to get to the next value, so here tangent of theta is positive because it's positive divided by positive. Here it's negative divided by a negative, so tangent is positive. So I'm not adding a full circle, I'm adding half of a circle. So the coterminal angle here is not 2 times n times pi, it's just 1n times pi, which we write as n pi. So it's the same approach. And for the negatives, it's the same idea. How far apart are these negative tangents? Just a pi over 2, not a full coterminal angle. So that's going to happen with tangent and cotangent. Now, what we need to be careful with is the algebra. So something like this. It might be tempting just to divide both sides by cotangent of x and then cross these out. We can't do that for multiple reasons. So first off is we're getting rid of a certain amount of answers. Also, what if cotangent of x is 0? We are dividing by 0. That's a big, can't do that. So instead, what we could do is we could subtract 2 times cotangent of x from both sides. So we get cotangent of x, cosine squared of x, minus 2 times the cotangent of x is equal to 0. Now, because there are 2 terms with a common factor, we can factor that out. So we get cotangent of x is equal to cosine squared of x minus 1 is equal to 0. Oh, sorry, that's I factored out a 2. Cotangent of x divided by cotangent of x. We get the 2 from that 2 there. So we can't use a trig identity, so we're multiplying these 2 together to get 0, so we can set them both equally to 0. So cotangent of x is equal to 0, and cosine squared of x minus 2 is equal to 0. This part is tricky but easy. We actually get cosine squared of x is equal to 2, so cosine of x is equal to plus or minus 2. So where on the unit circle am I going to have an x value of plus or minus root 2? Nowhere. The largest x value I can have is 1. So the square root of 2 is like 1.4 or something like that. This doesn't work. This is what we call extraneous. So there's no solution from that. So then we just have cotangent of x is equal to 0. So where is the cotangent, which is x divided by y? Where is that 0? Well, if we look at these values here, x divided by y, this would be pi over 2 and 3 pi over 2. But rather than saying pi over 2 plus 2n pi and 3 pi over 2 plus 2n pi, yet again notice I'm just going half of a circle. So I can say that the answer here is pi over 2 plus n pi. Yet again, when we have this cotangent or this tangent, we're adding n pi as opposed to 2n pi. That's the gist of the type of problems that we're going to be looking at. Really, it's just more applications from the unit circle. So make sure that you still are familiar with these values and make sure that you're comfortable with the algebra. But it's the exact same thing as finding the inverse values, the inverse trig functions, except now what we're doing is we're finding all values inside a unit circle and beyond.